Gothic cathedrals represent one of the high points in Western architecture. Their builders wanted to construct places of worship with upwards-looking spaces and light-filled interiors, features that spoke of the God they worshipped. To realize these grand goals, generations of builders from the 12th to 16th centuries were forced to make dramatic advances in both architecture and engineering. Their efforts gave rise to many innovations, including large buildings with complex vaulted ceilings, high stained glass windows, pointed arches that reduce lateral loading, and flying buttresses that can support tall, thin walls while letting the sun shine in. For thousands of years leading up to this time, most buildings were constructed using posts and beams. The vertical loads carried by the beams resulted in simple vertical loads in the posts or walls to which they were attached. Beams, however, could not stretch across the much wider spaces required for the new cathedrals. Arches, like this model, or this simplified model, could span these large distances. However, they generated large horizontal forces at their ends, and they could collapse if those forces were not adequately resisted. Short, thick walls might be able to resist these forces, but the cathedral designers wanted tall, thin ones. And they wanted to put large glass windows in those walls so the sun could illuminate the inside of their cathedrals. The horizontal loads generated by arch ceilings would have easily pushed over the kinds of walls they wanted to build. One possible solution to this problem was to pile stone on the outside of the building so as to support the wall. Over time, the engineers developed structures called buttresses, and these elegant structures could be found in many early Gothic cathedrals. Unfortunately, they tend to block the sunlight, as this model demonstrates. In time, designers figured out how to build thin lateral supports called flying buttresses. The earlier buttress designs were essentially broken into separate tall pieces and moved a short distance from the side of the building. The resulting tall sections were called piers, and they were connected to each other and to the side of the cathedral using sloped, arch-like members called flyers. As this model demonstrates, flying buttresses kept the tall, thin walls from collapsing, and they allowed the sun to shine in. This drawing shows how the forces from the vaulted ceilings were transferred to the flyers and then down through the piers to the ground. Spires and other heavy architectural features were sometimes placed on the tops of the piers so that the lateral components of the arch forces could be more efficiently transferred to the ground. By spires, we mean the high pointed tips of the piers. As you can see, the resulting buttress systems can be quite complicated. Since the designers did not have computers to help them, they relied on scale models, the much more sophisticated ones than ours. Those models helped them to fine-tune their designs, and they showed them the right order in which to build the various parts of the cathedral so that it would remain stable during construction. In what order should the components of this cathedral be built? Let's try building the shell of the building first. Oh, that turns out to be a poor choice. It's a good thing that this is just a model. Let's try again. This time, let's work towards the center and start with the most distant flyer. Then add the inner flyer, and finally add the arch. If we take our hands away, the cathedral model stands. The model has taught us that this is a much better construction plan. Once the stonework in a cathedral was finally completed, it was typically covered with a slate-shingled wooden roof to keep off the rain. We hope this video helps you to understand why Gothic cathedrals are such a triumph of architecture and engineering. Besides their beauty, many Gothic cathedrals have remained in service for more than 700 years, and they continue to inspire those who visit them. We hope you will consider watching some of our other engineering models videos.